welcome to the end of week 5. Our mini project for this week is memory. So memory is a card game in which you deal out a set of cards and you flip them over 2 at a time. If they match, you leave them face up. If they don't match, you flip them back over. The goal is to end up with all the cards face up. To build kind of a computer version of memory is not going to be too difficult. The code you're going to write is fairly short. However, you shouldn't underestimate the difficulty of this project. We're going to use some concepts that are kind of new to you, and so you should pay attention to this. In particular, we're going to use lists. We're going to use lists to kind of represent the cards and whether they're visible or not. We're also going to need to keep track of the state of the game. As you play a game of memory, where you are in the game changes. And so we're going to have to talk a little bit about how to kind of keep track of game state inside your games. I'm going to do 3 things in this lecture. I'm going to walk you through the program template for memory. I'm then going to show you another program that's separate that kind of keeps track of the game state inside memory. You'll need to kind of take some of the logic of that program and integrate it into your implementation of memory. And then the final thing I'm going to do is I'm going to invite in a special guest, and we'll play a couple of games of memory. Okay, let's go to lecture. Okay, let's take a look at the program template for memory. So I'm sitting here in CodeSculptor and I've got the entire program template loaded in. In fact, I've actually just got my implementation of memory loaded in here. I've used code folding to hide the implementation of kind of the 3 most important functions in memory. So in fact, my implementation of memory is only 60 lines. If you take a look at the program template, it's about 25 lines. So really, my kind of extra code that I need to add to implement memory is like on the order of 30 to 40 lines. The 3 functions that are critical are new game. It kind of sets up your data structures for a new game of memory. Mouse click is kind of where most of the logic for the game will actually take place. And draw is going to be something that's going to kind of go through and draw all the cards on the canvas. Even though the code is fairly short, it's actually surprisingly tricky. You're going to need to work with a list here. You're going to need to work with a list that stores kind of the value of the cards. You need to have a list that kind of keeps track of whether the cards are exposed or not. You're going to have to iterate through these lists. You're going to have to do some logic that kind of keeps track of kind of the state that the game of memory is inside. So the thing that I want to do next is let's just play a couple of games of memory and kind of give you a feeling for how memory actually works. So here I fired it up. We see a frame. Here we see kind of the 16 cards laid out horizontally. Notice over we have a button restart that restarts the game. And we have a counter here. This is a label, which we're going to update using setText, which keeps track of the number of turns in memory. So a turn in memory consists of clicking on 2 cards. If the 2 cards are paired, when I click on another card, those cards are flipped back over. If they're paired, we leave them exposed. If they're unpaired, we flip them back over. And so the goal is to actually get all the cards exposed on here using the minimum number of turns. So let's play a game of memory. So we're going to start out, notice that they're kind of 0 cards exposed. This is going to be kind of the key to understanding the logic of memory. If I click here, I have 1 card exposed. If I click again, I have 2 cards exposed. Since these cards are not matched, when I click again, I flip over the new card and I flip the other 2 cards back over. Okay, so I'll click here. These cards are not paired, so the next card I click on is exposed. These are flipped back over. Now at this point, I could expose 1 more card, and now if I'm smart, I think I can start pairing them up. Let's see. I'm going to click a 4 here. Oh no. There's a 4 and a 4, so now let's go back, and these are going to flip over. I get a 4 and a 4. And let's see, I think I saw a 0 back here somewhere. I did. So I'm not very good at this, but I think there was a 0 here and a 0 there. So notice the way the logic worked is, in some sense, there were always, after we started the game, there was either 1 card that was kind of we were working with, or there were 2 cards that we were working with. All the other cards that are kind of previously paired, we could just kind of ignore. So that's going to be kind of the key for the logic for how we're going to actually implement memory here. A few other things to note about this. I'm going to be fairly strict. I'm going to ask you to ignore clicks on existing cards that have already been exposed. So if I click on this 4, nothing happens. If I click here and expose a 3, I keep clicking on it, nothing happens. The turns don't change. That's going to make kind of assessing whether your implementation of memory is correct or not a lot easier in here. I know some of you would like to be a little more kind of, I guess, do kind of variance of it, but I'm going to kind of ask you to be kind of, in terms of the logic, to be kind of conform to the mini project description. If you want to experiment and do something kind of fun, go through and you can actually experiment with building a grid of cards that's, for example, 4x4 instead of kind of 1x16. You could use images for the cards instead. Those are places where you can kind of riff and build some kind of nicer implementations of memory if you'd like to experiment. The thing that I want to do next is I want to go through this kind of this process, this logic of kind of keeping track of what cards should be flipped over and what cards should not be flipped over. And to that, I'm going to actually show you some code that you could use inside your mouse click handler. So let's go do that now. Okay, I've written a piece of code that kind of hopefully will help you understand how to implement the logic from memory. So here it is. The critical thing is I've built this button handler that's going to have kind of similar logic to what your mouse click handler should exhibit. You're going to have a global variable called state. When you start the game, state's going to be 0, and as you click this button, or in memory you click the mouse, the state is going to be updated. If we're in state 0, we update the state to 1. If we're in state 1, we update the state to 2. And if we're in state 2, we update state to 1. Now, the critical thing here to understand is what does this number 0, 1, and 2 represent? The way I like to think about it is it represents how many cards are currently exposed in memory. Now note, we're going to ignore all those previously paired cards. In some sense, those cards are done with. We're not going to worry about those. But we're going to always have kind of 0, 1, or 2 cards that have been exposed, and we have to think about what to do when we do the next click. So let's run this real quick, and then I'll kind of walk you through it. So here's my little application. We've got a restart button like we'd expect, and we're hit restart. We start out, there's 0 cards exposed. We kind of saw that when we ran the game. If we simulate a mouse click, we've exposed 1 card. If we simulate another mouse click, now 2 cards are exposed. Now the critical thing here to note is that if I click again, those 2 cards, something happens to them, either they get flipped back over or they're paired, but now there's 1 card exposed. I simulate a mouse click, there's 2 cards exposed. Now at this point, when I click again, those 2 cards are previously exposed. We either say, good job, they're paired, we ignore them, or we flip them back over. So you can see here inside my code that really what's going on in here is I've just got a little collection of kind of some if clauses here that are going through and manipulating this variable. Now the critical thing is, where do we need to put in the code to check to see if the cards are paired? We want to do that when we're in state 2. So when do we end up in state 2? It's right here in this else clause. So you're going to need to actually add in some logic here that check the previous 2 cards. You're going to have to keep track of those previous 2 cards that you just exposed and check to see if their values are the same or not. If they're the same, we leave them alone. If they're not, we flip them back over. And that's really the critical aspect of the logic of memory here. So you might kind of take a look at this code, play with it, kind of understand what's going on. And so this code here should actually be moved inside the mouse handler when you're implementing memory. Okay, let's go on now and have some fun. Well, I promised you we'd play a game of memory. Now my plan had been to have somebody with a eidetic memory come and join us, somebody you probably all know from the class and really, really like. But the copyright police actually foiled that plan. So instead, I've invited somebody else who has a eidetic memory to come join us and play a game of memory. Come on, Scott.
Hello.
All right, Scott, you want to play a game of memory?
Count me out.
What? Come on. Come on.
You want me to use my intelligence in a tawdry competition? Would you ask Picasso to play Pictionary? Would you ask Noah Webster to play Boggle? Would you ask Jacques Cousteau to play Go Fish?
Yes, I would. Especially if it's you.
All right, fine.
All right, we're going to play a game of memory here, and we'll see who's got the best memory. By the way, Scott, that was almost as good as Sheldon did. Just stay a professor.
All right. Well, we've got it loaded up here. Memory's ready to rock. We're gonna let Scott go first, and then I get to go second. We'll figure out who wins ties when we're done. I'm hoping for a tie at this point here. All right, Scott, give it a shot here. All right. Okay, Scott. Now you need to click in the green squares.
All right.
I want to make you laugh so much. There's no way you can do it.
Oh, hey, see, I know what I'm doing here.
Is this going to be a replay of Pong again? I'm going to have to check this code afterwards. They say, "Oh man, I am. Oh no, I'm totally doomed. What is this?
Oh, what was that?
Oh, hey, all right, that's it. Oh god, what is it now? Oh my lord, I'm doomed. Oh, that's what. Something's wrong here. I think this is like for 6. Yes. All right.
15.
I have a little bit of a chance. I don't think your memory is quite as photographic as you think.
Yeah. Well, at least I own more than one shirt. What's with that black shirt anyway?
All right. I can explain the black shirt. Okay. I don't think I'm Steve Jobs. Here's the difference. One, brilliant egomaniac. The other one, founded Apple. All right. All right. I'm going to demonstrate. Well, we'll see. I'm not going to demonstrate anything except I'm probably really bad at memory here. All right, here we go. Come on, baby, be good. You got lucky there.
3, oh, come on.
No.
I had one by now. I already had one.
Oh,
you
God, I'm like totally unmatched. 7! I'm totally mad. I think we're going to have a system crash here in a second. Oh, jeez. There's no way I remember where 6 was. Can we rewind the videotape here?
Nope. This is an easy victory for me, I'm pretty sure.
God.
I don't know what you're talking about.
Yes!
Oh, pulls one out.
Come on. 3.
Yeah, you have no idea where that is.
Yes! Oh.
Yeah.
Oh, yes!
Oh, man, this is looking bad.
6. Square was 6.
Nope, that's not it.
6.
It's not right there. Oh, it wasn't right there.
Oh, shoot.
Now. Oh. Yeah, you have no idea where 1 is.
The truth is, I don't. Oh, yeah. Oh! 7. What was that? Where the heck was 7? It's there.
Nope.
Oh, God, no!
Nope.
All right.
This is it.
I have to do this.
Better
one.
get it right. Oh.
I think it is! Oh, yeah!
Man, so lose by 1 to the Steve Jobs wannabe. I don't know.
Alright, that was totally unplanned, by the way. Alright, we'll see you guys next week.